Okay, so our next speaker today is slightly closer to home. It's Dr. Boyd Duffee, who's a computer scientist. He's a CPAN author and data scientist, and I believe in your email to me you said you were a Perl Data monk by night as well.
Lies, all lies.
He's going to be talking today about PDL, the Perl Data Language, for those who are impatient to learn that. Over to you.
Okay, thank you very much. And I blame the organizers for letting me inflict myself upon you. This is a sales pitch. It's not a tutorial. And like any sales pitch, you need to verify this before you buy. But if you have lots of numerical data and you want to crunch it really super fast, you'll be saying by the end of this, I got to get me some of that. So what are we talking about? PDL is vectorized data structures, the official language, and I will mangle a lot of terms. But essentially, these data structures are laid out in a compact form. They are easy to traverse, and since the module is written in C under the hood, it's very fast. Let's see. You lose some of the flexibility of Perl. You have to pre-declare your dimensions and your sizes, but you get so much more for being able to do that. Now, this has been around for 28 years now. It's been around a long time. It was released before NumPy, but Python programmers drop into NumPy at the drop of a hat. Perl has had a lot of other modules available to it, so they can reach for that before they go for the big guns of PDL. And in my view, you'll correct me after in the pub, but when it was released, it got a lot of attention for about 5 years. They built everything that you needed to do with it, and when it got to version 2.4, it plateaued. And people went on and got doing the stuff that they wanted to be done, and they stopped talking about it so much. There's a few YouTube videos out there. In the last 5 years, we have seen about a release every month. It's now up to version 2.93, and Ed and the team have been squashing bugs and improving performance. It's been great. And a little thing is that to conform with everybody else in the rest of the world, we're now calling them ND arrays for n-dimensional arrays because they could be of any number of dimensions. Let's see. Getting data in. It will take just about anything. It will do what you mean as long as you're sensible about it. If you don't have pre-existing data already, you can use some of the helper functions. You can give it the size of all the dimensions that you want and fill them with zeros, ones, random numbers, whatever you want, a sequence. You can also get data in by importing a file. It started out in the astronomy community, so it deals with FITS file formats, but lots of other file formats are available. Getting data out. PDLs are stringified. They're not that pretty. I had to compact this. If you have a lot of data, a little bit like Luis had, it'll get unreadable. You can bring them back into Perl to un-PDL things. You can write it to a file. The one thing that I haven't mentioned here is that you can output to images, graphs, either two-dimensional or three-dimensional, depending on the packages you have available on your system, and because everybody has something different, then it depends. Okay, vectorized broadcasting means no nested for loops. So if I want to do an operation to every single element of your PDL, just say 5 times your vector, and you'll get another vector, the same size, just modified. There's a lot of do the right thing about it, so you can multiply 2 different PDLs together. As long as they match in size, it'll try and do the right thing. You can do matrix multiplication. And if you have big data and medium memory, you want to do a lot of things in place. So there's a little bit of a be careful about what's a reference and what's a copy. because if you modify the underlying data structure, it will modify the the things that refer to it. Right, a few features. We have good values gone bad, and this is what happens whenever either you have equipment that's faulty, just missing data, and if you try and do it naively, you're going to miss a couple of things, like if you say that I'll set all the bad values to 0, well, your average is wrong. If you use not a number, well, if you throw it through Q-sort or median, then your median is wrong. A bad value is just don't calculate with this, and bad values propagate. So that's very useful, and it helps you do the right thing. Masks are not just for COVID anymore. Let's see, you can slice and dice and transpose rows into columns. You can move dimensions around. You can create what they call masks. I had an image here that if you wanted to measure the brightness of the outside of a galaxy, then you would want to block off the center of the galaxy and do the operation on the outside. You create a mask and sum over everything else in there. I'll say read the docs. I'll leave it at that. It has a read, eval, print loop, and it has since pretty much the beginning. This is a really good way of exploring data, getting to know PDL, trying out new ideas. You don't need the semicolons. You get immediate execution, and you have a history so that you can go back and edit your commands, try new things out. For example, the shortcuts, the P for print. So I create a sequence from 0 to 9, and I print it out, and I get that. Right.
The next version we have X, which is a
data dumper.
Data dumper, yes.
Okay, excellent. Let's see. Tons more things, lots of modules, and I will hint at a few of them. The stats module not only will give you distributions, but it'll also give you clustering through k-means. I haven't tried linear modeling. I got a book on time series analysis, so next year's talk will be on time series analysis. I don't know anything about it yet. You can fit Gaussians, exponentials. You can do downhill simplex routines and linear algebra. And for the Apple fanboys and girls, PDL just came out this year, written by the OG author himself. I think he just got a MacBook. So that's it. And lastly, not leastly, the websites that you may want to be, they managed to get pdl.perl.org. That's really what you need to start with. And it will tell you where to go for the mailing list, for the book, for the IRC, and where the GitHub repo is. And at the very last, I'll point out, this is me. I am Duffee on GitLab, GitHub, and CPAN. And I stole somebody else's 100 PDL exercises, which were stolen from Python. And I added a few more. I completed a few more of them. There's still a few to do, so if you want to help out, that's great. But that's me. Is that 5 minutes?
Yeah.
Okay, all right.
So thanks. I'm done. Great, very interesting talk. Something I'm probably going to start looking at myself. And any questions from the audience?
Was that too fast?
Absolutely fine.
I kept up. I've had
Okay.
very easy to follow.
I did not, and I'm curious to learn more. So.
Okay, that's the whole point. I really want to have a 5-minute talk out there that will get people into learning more. So that was kind of...
is it approximately, and I'm asking this from the perspective of someone who doesn't really know Python either, but is it like NumPy then, sort of equivalent?
Yes.
Is that so?
Can we say that?
Like,
It's better.
I would say it's better. PDL around since 1996. NumPy since 2009, and yet they took the decisions that PDL made and did them differently and worse. which is bizarre.
Oh,
As in, like, performance-wise worse or
Well, it
feature-wise?
is slower.
Okay.
So has written some recent paper to show that PDL does go slightly faster, thanks to the thrilling. But also just design decisions, like how it handles the images. I can bore you at the pub.
So basically, if because I see a lot of Python around, like work things and other stuff, and when I see NumPy in the past, I thought, oh, well, that's clearly a thing Python's got that Perl hasn't got, but I just didn't know about this. So
it's strange how few people know about it. Absolutely, anything NumPy can do,
this
probably PDL can do either now or tell me about it.
the only book in PDL is online. There is no print version.
That's
That's the book, and I don't know if we can change that or anything, or well, I don't know.
What do you mean?
What as in can we?
people don't want real books anyway. These days.
Okay.
Online is better.
Sorry, dead trees? Yeah.
Well, I don't know.
Okay.
But that got updated recently because I think it used to be book/pulp, didn't it?
Right. Okay.
And basically, the PDL book, which was for a long time only in PDF, is now, I just basically put it on the website. So the entire book is there. And I did that because someone was moaning about how the EPUB fonts were wrong.
Okay.
So I, half an hour later, I did a bit of web dev and updated it. It's like HTML. There you go.
Okay.
So I come from the oil and gas industry. So I work in Saudi Arabia and a lot of AI stuff. And it's not my bag, but Python is the de facto bandwagon tool.
Yes, it is.
Universities, and I think Perl is viewed as prehistoric, which I know is wrong, but I don't know how to engage that conversation with people that there are alternatives out there. And every software application, commercial product we use has a Python plugin to it. And I think if this is to grow, we have to get into those applications. And I don't know how you do that. This is not my specialty area, but I'm a low-level Perl programmer, but I hate the bandwagon effect of Python. It's like, anyway, so I'd like to learn more about this myself.
Okay.
I have another question.
Go
on. Do you have a feel for how the performance compares with things like MATLAB or Octave? And also, is it faster in terms of the computation speed than crunching stuff that's written purely in Perl?
It's much faster than crunching and purely in Perl.
Yep.
I have no feel for MATLAB or Octave.
I can have a guess without having tried it. You don't use those for performance. That's not. I mean, MATLAB, commercial MATLAB has some proper full retard, powerful computation stuff which you pay for. PDL is just sort of in the slow mode. There isn't really a fast mode yet, as using GPU, or watch this space. But I would be very surprised if, in the routine way, that MATLAB was faster, because they're not for that.
No.
So our researchers, they all use MATLAB because that's what they learn in university. What little I do know is they make fantastic graphs of functions and stuff. Is that?
It's a fantastic development tool, let's say. So like the REPL there. I have used MATLAB. Sorry, not MATLAB. Yes, MATLAB built online. Just there's an online web version used for free. Octave I've used somewhat, just sort of check numbers for PDL stats. It has a bug. In the analysis of variance, which I don't understand yet, so I have to learn it a little bit about it. I mention this because MATLAB it's commercial, and their audience is those people. So it's really good for developing and prototyping is the word. Whereas PDL is probably a bit less good, a bit less shiny. If you have specific feature requests that make it better, tell me.
Why don't you MATLAB? Because they create real executables, real programs.
But they won't necessarily, yes, but it's still, in terms of performance, it's like a prototype. But I could probably measure that and let you know.
It can be the question of how big are your data structures and how long is it taking currently? Can we shave something off that? I'd like to get some more, I guess, APIs and written in PDL. That would be great. I have time coming up. So if and stats, yes, I'm willing to throw some time in behind that, Ed. We will talk.
Please, because I need someone to check some numbers for me, and it's been the case for about 3 years.
Okay.
And I never. Someone just pointed me at R. It's like, oh, let's go for stats, because I made a change to fix part of the bug.
Mm-hmm.
Several bugs there, and it's changed some of the results that are there in the test already. It's not. So please.
Okay. All right.
Quickly, on the sort of like versus other statistical kind of software and technology.
Yeah.
Am I right in thinking, Boyd, you were saying earlier, there's like kind of, is there something like if you're a MATLAB person, here's how to here's a quick guide to PDL for MATLAB people. And
yes. It's called
people.
PDL MATLAB. It sounds like I'm mocking God. On CPAN, it's with the PDL distribution. And if you're going to bring up the web page, please look at that first.
Can I? I'll ask Andrew. Can I just put this into a browser somewhere down here?
Sure.
All right.
Because I also want to just highlight that there is a quite nice set of demos that are recently added to. So on the left there, see.
But we will need to.
He's going to show you that.
All right.
So there's a lot on the PDL website.
So go to cpan.org. Look at PDL colorful. It's there. It's an intro thing. It features, I added this, an implementation with a Warshall algorithm, just compare between MATLAB and PDL.
Okay. So that's a documentation audio.
Yes.
Yeah. That's great. That's fantastic. So
Right.
fantastic.
So it's an inventory of, besides the gentleman before, what kinds of people are using this?
If there are no further questions, then that concludes Boyd's talk. Thank you very much.
You didn't mention that you're also a part-time